Position of the object is determined with the help of a point, and that point is known as reference point. Here we consider at certain precise interval of time the motion of an object which undergoes certain velocity as well as certain speed. If the acceleration, that is direction of acceleration, is opposite to the direction of the velocity, then you can say that it is deceleration because the velocity decreases. Here the velocity increases, there the velocity decreases. Hello everyone, I am Vrinda, Faculty of Physics from Vidhyaashram School of Excellence, Mysuru, welcoming you all to Chapter 3, Session 1 of Motion in a Straight Line. So, motion in a straight line, from here exactly the class 11 concept starts. Till now, whatever we had studied about the physical world or units and measurement, it was just the introductory part. So, here in case of motion in a straight line, we are studying the motion which occurs, that is a movement occurring in a straight path. So, in order to study this, first of all, we'll have to know what is meant by kinematics as well as dynamics. We need to study about kinematics as well as kinetics. So, kinematics and kinetics are two concepts which comes under dynamics. So, what is meant by dynamics? Dynamics is study of motion of an object. So, dynamics is of two types. One is kinematics and another one is kinetics, where in case of kinematics, we study about the motion without taking its cause for an account. Okay, so without even considering the cause of the motion, we just consider only the motion. That concept is called as kinematics. And when we just consider the motion as well as its cause, then it is said to be kinetics. Those three are the motion. One is with cause, another one is without cause, and which comes under the dynamics. So we have kinematics here, that is study of motion of an objects without taking its cause for an account. Okay, that is said to be kinematics. So here in this image you can see a cute little hippo is swinging. That means to say that we are not even considering its motion, what is the cause of its motion, but we know that there is a motion which is taking place, that is swing, going forward as well as backward, that too happily, right? So next we are going on to motion. So what is meant by motion? It means to say that movement of any object. Motion is always said to be a movement. Okay, movement of or displacement of any object when the certain force is applied on an object which is at rest. That is called as the motion. Motion of any object in the universe can be called as a movement, or it can also be called as a motion. Okay, so next, rectilinear motion. Since we are studying, this chapter is completely based on the motion in a straight line, we are considering about the rectilinear, which means to say that it sweeps a straight path. Okay, motion of the objects in a straight line is known as rectilinear motion, linear line motion. Understood? So this is all about the motion as well as rectilinear motion. By looking at this, you can see one skating is taking place, and skating is said to be a rectilinear motion. The clock is showing the time, so it can be called as circular motion, and the circular motion is with the help of this minute needle. Okay, and next we have rotational motion. That means to say whole ball rotates. Okay, the ball is being considered here and the whole ball starts rotating is said to be the rotational motion. And you can see periodic motion which goes to and fro movement. That means to say oscillation is seen there, which is said to be a periodic motion. And then you have a general concept of motion here. The last pic shows the general movement. Okay, so these are all the types of motion what we study. Motion means movement of any object which is at rest, that is by applying a force in order to displace the object. Next is rectilinear motion which follows the straight path. Next we are getting on to position, path length as well as displacement. Okay, there is position, path length and displacement. So this is one of the important concept what you have to know. So here, position of the object, how exactly we refer for the position of the object, that is determined with the help of a point, and that is known as reference point. Always, if suppose I'm standing over here and my final point is somewhere at a distance of 5 centimeter and this is my initial point, then I can just set a reference point that my final position is that fifth centimeter is there, no? That will be my final position. That means to say that I am setting a point over there which is said to be a reference point. Suppose if I walk 5 centimeters apart and stand there in the 5th centimeter and just watch my path from the initial to the point where I am standing, which is the final position, then I consider that 0th point as a reference point. That means to say that these are the position. It determines the position, which means to say position of the object is determined with the help of a point, and that point is known as reference point. Even while comparing yourself with any other person is there, no, those people will be your referral point. Referring to them, you will tell about you, you will talk about you, or your parents referring about some other kid, they will talk about you. This is what usually happens, right? So these are said to be the reference point. Okay, so reference point and set of axis. Okay, we should have a set of axis or the reference point in order to determine the position of the object. And this axis, as you all know, you study about the x-axis, y-axis as well as z-axis. Usually you have seen in these cases in mathematical applications, but here you will study about the axis in the next upcoming chapters as well as this chapter. Okay, so now we have the coordinate system, which means to say that 3D axis. That means 3 dimension, 1, 2 as well as 3 dimensions. You will have the coordinate system which represents the position of object with respect to time is known as frame of reference. If the point is known as a reference point, the coordinate system will be known as frame of reference. It creates a frame for a referral point. Okay, so that is all about your position. Now let us study about the path length. Path length is also called as distance. The path length is also called as the distance, the path which is taken, and you're calculating the length of the path taken. Suppose you consider this diagram. Here you study about path length as well as displacement both. Suppose your area is in this red line. Okay, red line is the actual way for you to travel. Suppose this is start and you can see a vehicle is moving there and this is the end point. So this is completely curved. So the distance what it takes is too long distance and the time taken is also higher. It is larger. The time consumption is more over in this case. That is, if you just follow the red path which is over here. Okay, so this is the total path covered. If you want to have a shortest distance, it is from start straight direct to end. Okay, so it is always like the path followed. Whenever you consider the path followed over here is taken into account, then it is called as distance. That is the total distance traveled by an object, the complete total distance without even subtracting a little bit of the distance, or the complete distance has been considered. Okay, so the complete distance, that the total distance is considered, total distance traveled by an object is known as path length. It is a scalar quantity. It is not a vector quantity. It is a scalar quantity. Though we know where we have to move, the direction for this distance is not being calculated. Okay, it is like the total distance has been taken, not from here to there, not from initial to final. There is nothing like the direction for this total path taken. It is only the total area, that is the total path which has been taken and a certain interval of time is called as distance. Whereas when you consider displacement, it is the shortest path, as you have seen. It is a shortcut area. So it is quantity which depends only on the initial and the final position. It depends only on initial as well as final position. That's all. From initial directly, which is the shortest distance, you just draw a line or consider those things. That is initial to final. What is the distance? That will be the displacement. But the total path followed will be the distance. Clear with that? So now, here displacement will be the vector quantity because we are considering from initial to final position. We know from where we have to consider to where. Okay, from to 2 condition has come here, so we call it as a vector quantity. Next, the magnitude of displacement may be or may not be equal to the path length traveled. If suppose start is this and end is this, and for the start as well as end there is one single way, this itself is the displacement and this itself is the distance. Okay, that is what it is told. The magnitude of displacement may be or may not be equal to the length traveled, path length traveled. So one is this condition, this is equal. Displacement and distance both also are equal. In the previous image, that is this image, distance is not equal to displacement because that is the shortest distance and longest distance, and the magnitude of displacement may be 0. How can you say? The magnitude means to say that it is a value. The value of displacement you can tell it as 0. How? That is, suppose you take a circular path. You have traveled a circular path. Your initial position is this and your final position is also this. That means to say that you are referring the distance from initial to final is said to be 0. Okay, then the displacement is said to be 0. That means it has come back to its initial position. You, starting from your home to school or college, getting back to the home itself after your college is done, right? So when that is the case, if you take the initial and final position, you have started from home, you're ending at home, which means to say that the displacement whatever you taken is 0. Understood? So suppose you start from your home to college and from college to home. So total path length taken will be calculated as from home to college and college to home, it will be added up. This is the distance. So I hope it's clear to you by this example. Next we are going on to velocity. We studied about motion. In order to check about motion, we need to know, that is, if you call the body is said to be displaced, then you should know from where exactly it is displaced. In order to know from where exactly it is displaced, you need to know regarding the reference point and frame of reference. Having those concepts within you, you have something called as velocity. So what is meant by a velocity? Velocity means the rate of displacement with respect to time is said to be velocity. So velocity, that is with respect to time, means it is a vector quantity. Okay, rate of displacement with respect to time is said to be velocity and it is said to be a vector quantity. So velocity is given in terms of v. We call it as a vector quantity, which is equal to the rate of displacement. We have displacement, that is change in the position with respect to time. Okay, change in position with respect to time is said to be your velocity. There is change in position with respect to change in time, because time is not a static condition. It keeps on moving. That means there is change. With respect to that change in time, there is change in the body's displacement also. That is, the body gets displaced. This is what exactly the relation tells. Velocity is equal to displacement by time taken is said to be the definition for this velocity, and it is a vector quantity, because of which we have mentioned vector. You got to know why velocity is a vector quantity, because I had told you that displacement is a vector quantity. Okay, that means to say displacement is a one which depends from initial to final. That from and to condition is there, which gives you the vector quantity. Next is average velocity. For average velocity, the ratio of displacement of the body to the time interval in which displacement occurs. Average velocity, here we consider the two displacements with respect to certain interval of times. That is, suppose if the body is at displacement x1 at time interval t1 and x2 displacement, that is a final position, at time interval t2, then you will have the velocity is equal to average velocity is equal to AV. Average velocity is equal to displacement by time taken. That is change in displacement, which is said to be x2 minus x1 with respect to t2 minus t1 will be the equation VAV. Okay, so this will be the equation for the average velocity. This is how we calculate. When there are n number of displacement with respect to time, we just consider final as well as initial condition in order to know its displacement, and displacement at certain interval of time, that time thing is taken over there and then it is been equated. Then if you just come to the dimension formula of the velocity, dimensions for this velocity, we know that velocity is equal to displacement by time taken. Okay, so displacement means the length which is being considered, which means to say that the dimension for this displacement will be length. Its SI unit is meters. I'll come to that. And time taken is given by T itself. So L and T, which means to say mass is 0, L to the power of 1, T, since it's in denominator and comes back to numerator, it becomes minus 1. M naught, L1, T minus 1. Without considering M naught also, you can write, because anything to the power of 0 is considered to be 1. The value is 1. But usually, standard ways, you consider M as well as L as well as T altogether. M, L, T is mandatory. If those things are not there, you can just put to the power of 0. Now, coming to its SI unit, suppose if you want the SI unit of this vector, how is that you will write? SI unit is equal to, how do you consider the length as? The SI unit, that is standard unit of the displacement or the length, is said to be meters, divided by the unit of time is always calculated in seconds, or you can even give it as meter per second, or even you can write it as meter second inverse. This is how exactly you give the SI unit of the velocity, its dimension, as well as what is meant by average velocity. Having all these concepts, now let us go to the speed. What is meant by speed? So, in case of speed, when you consider speed, the distance moved by a body per unit time. For certain interval of time, what is the distance which is moved? So, here we consider the distance. And since distance is a scalar quantity, speed also is called the scalar quantity. Okay, so now speed is given as, speed is equal to distance by time taken. So you can just write it as x divided by t. Okay, so here you have average speed for it. So average speed means total distance traveled to the total time taken, which will be considered under the same equation. That is all about the speed. This is the difference between speed as well as velocity, where velocity we consider the displacement, speed we consider the distance, and usually while working out we consider the velocity concepts. Okay, so next we have instantaneous velocity and instantaneous speed. The name itself tells instant, at certain instant of time, its velocity as well as its speed. Here we consider at certain precise interval of time the motion of an object which undergoes certain velocity as well as certain speed. Coming to it, the rate of change of position of a body at a particular instant of a time at a particular point on its path is called as instantaneous velocity of a body, which is given as v is equal to, that is velocity, vector quantity velocity is equal to, you have delta x divided by delta t, change in displacement with respect to time, and the condition there exists, that is there is a limit where the delta t tends to 0. This is the limit condition what we apply for certain velocity as well as speed. Okay, that is the limit condition. Within that limit, we have got the position of the body at certain interval of time. That is a precise time what we take at that instant of time. Okay, same, the instantaneous speed at an instant is equal to the magnitude of instantaneous velocity at that instant will be considered to be the instantaneous speed. And what you can see here, at certain instant, what is its speed, or at certain instant, what is its velocity is the usual thing what we consider. Having this concept, we are just moving on to uniform and non-uniform motion. Uniform motion, non-uniform motion. Uniform means to say that, like, suppose you go to some school or something, like you can see there, the students are completely have worn the uniform, right? And each one of them looks similar. Each one of them are same. Though they are different in the culture as well as tradition, or they are from different families, once they get into the school, they maintain uniformity, which means to say that all look similar. Okay, similar way we have uniform means to say that the object which moves along a straight line, since this chapter is completely regarding straight line, the object which moves along a straight line, it covers equal distance in equal interval of time. This point is the main point, okay? Covering equal distance in equal interval of time is said to be uniform motion. There is motion because the particle is said to be moving, or an object is said to be moving, because of which you can say it covers equal distance in equal interval of time. Similarly, you have got non-uniform motion. Non-uniform motion means there is no uniformity. There also there is certain point, that is, it covers unequal distance in equal interval of time. Time cannot be unequal. Time is always equal. So both the cases it is equal interval of time, equal interval of time. Only unequal part is this one, that is unequal distance. Here it is equal distance. So suppose if an object travels equal distance in equal interval of time, it is called as uniform motion. Suppose it travels unequal distance in equal intervals of time, then it is called as non-uniform motion. You can see here, O to A, 2 seconds. A to B, again 2 seconds. Again B to C, again 2 seconds. So time is also at 2 seconds, and 0 to 4, 4 to, again this difference is 4 meter. Here also the difference is 4 meter. Here also the difference is 4 meter. Same meter is been, distance has been traveled at same intervals of time. Whereas in this case, here 2 seconds it moves just 1 meter. Here again for 2 seconds it moves nearly 9 meter. Here again for 2 seconds it moves 15 meters ahead. Okay, so these are the changes what occurs. So there is unequal distance, but time is said to be equal. So this is one of the image in order for you to understand regarding the uniform motion and non-uniform motion. Next we are having acceleration. So what is meant by acceleration? Whenever there is a velocity, if there is a motion for an object, then you can say that there is a velocity. Suppose if the velocity is not uniform, like you have studied in the previous thing, okay, an object, if it has to have equal path taken in equal interval of time, it has to move in same velocity throughout, correct? Suppose if it covers unequal distance in equal interval of time, that is, its distance, its speed increases as it goes further, or its speed decreases as it goes further, either of the two, there you can say that there is change in its velocity, that means change in its speed, which is said to be nothing but acceleration. Acceleration means rate of change of velocity, change in speed with respect to time is said to be the acceleration. Okay, so it is given by the equation acceleration A is equal to change in velocity with respect to time is said to be acceleration, and average acceleration, if you just consider change in velocity to the time interval, okay, it is the same. Average acceleration means if it has got V1 velocity, first kind of velocity at time t1, and V2 will be the another type of velocity at t2, either decreased or increased. So when you write average acceleration, you will have V2 minus V1 divided by T2 minus T1, which means to say that change in the velocity to the with respect to time interval, that is with respect to change in time. Okay, so it can be called as a vector quantity because you know that velocity is a vector quantity, then acceleration can also be a vector quantity, and the SI unit of this is velocity. Velocity means it is displacement by time taken into dt, this time taken. So it is displacement is given in case of length, that means to say that it is calculated with the help of meters, divided by t and t, time and time. Time into time is second into second, so it becomes second square, or you can say meter per second square, or you can say meter second minus 2. So this will be its SI unit. And when you come to this dimensions, when you just plot the dimensions you have, so you have x divided by t and t. So suppose you take A is equal to dv by dt, which is equal to velocity with respect to time. So velocity is L, that is length, divided by time taken into time taken over here, which is equal to, you don't know what is L, no mass has been there, but L is there, T minus 2. So M naught L1 T minus 2 will be your dimensions. Then instantaneous acceleration is said to be the acceleration which occurs at certain interval of time. So that is all about acceleration, and next let us go deep into the acceleration stuffs, because we need to check out how exactly it's been differentiated. So what are the types of acceleration, when we say it as acceleration and when we call it in other words, let us check on it. So acceleration means direction of acceleration is same as that of the velocity. That means to say that magnitude of velocity increases. You know that velocity is there. If the direction, that is change in velocity, occurs, that is if the direction of acceleration is with respect to the direction of velocity, then you can say there is increase in its velocity. Okay, that means to say that it is termed as acceleration. There is another name, that is deceleration. So when can you say deceleration? If the acceleration, that is direction of acceleration, is opposite to the direction of the velocity, then you can say that it is deceleration, because the velocity decreases. Here the velocity increases, there the velocity decreases. Next you have centripetal acceleration, which means to say if the direction of acceleration is perpendicular to the direction of velocity. That means to say, suppose if this is having a circular path and here there is a center and there is an object which is connected and it is having a force towards the center, whenever an object is allowed to rotate, this will have a force which is called as a centripetal force, and the direction of acceleration is perpendicular to the velocity. This is velocity, this is direction of acceleration, so that you have perpendicular to the direction of velocity. Then the magnitude of the velocity remains the same, but the direction of the velocity changes. This is what it is, which is called as centripetal acceleration. And then you have uniform acceleration, which means to say that change of velocity by equal amount in equal interval of time. Every time there is equal change in its velocity, because of which you can say it as uniform acceleration. So now I hope you got it. Acceleration, deceleration, centripetal acceleration, as well as uniform acceleration. Next we are getting on to position time graph. Exactly what is position time graph? Here we study about the position, and x is the one which gives or determines or represents position. Time, t is the one which determines time. Okay, so you draw a graph which has x-axis as well as y-axis as well as origin in general, and these axis has got position time graph. So here we plot the position, that is x, and here we plot the time, that is t. This will be in meters, this will be in seconds, and this will be in meters. So this is the general thing, that is the general sketch of the plotting graph. You have position time graph, position with respect to time, or position versus time graph. All three ways you can just explain. Okay, so here few of the position time graph, according to certain titles whatever is given, we need to plot a graph. So let us do it. So our work is to plot a position time graph. I'll just put one question, that is, for an object which is at rest, if we just tell that object is at rest, what is the graph of this? We have x as well as y, x-axis, y-axis. This is position, this is time graph. So this is origin. So if suppose our object is said to be at this position, if this is 1, this is 2, this is 3, this is 4, this is 5, at 1 minute, at 0th minute your position is here, at 1 minute your position is here, at 2 minute your position still it's here, at 3 minute your position is still there, 4th minute also there, 5th minute is also there. So when you draw a line, it is just a straight line what you get, which means to say that when the object is rest, the position time graph obtained is a straight line. Okay, and the curve under this graph gives you the velocity. Okay, the curve on this, because velocity is nothing but change in position with respect to time, is nothing but your velocity. That is why the curve under this position time graph is said to be velocity. Next, we are going on to the second graph. So let us opt for this. So there is x in meters and time t in seconds, and this is in meters. When we check on this, we just plot a graph for an object with uniform displacement covered with respect to time, or else even you can call it as uniform velocity. Displacement with respect to time is always a velocity. So uniform displacement is being covered means to say that uniform velocity. Suppose if these are the time intervals and these are the meter which is covered, at origin it will be here itself, and after certain interval of time it moves 1 centimeter apart, and after 1 centimeter moving the time, it moves again forward. Okay, if suppose this is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, again at 3rd second, 3 seconds, it moves 3 meters. So 3 and 3. Again at 4th second, it moves 4th meter. So it is here. So when you just draw a line, it is a straight line what you get. That is completely a slant and a straight slope what you get. So that you can consider as uniform. When the object is moving with a uniform velocity, you get such kind of a graph. So I want you, all of you, to remember and have a logic on how to plot the position time graph with the details which we get. Okay, there is not necessary that you have to put 1, 2, 3, 4, 5, all this. You can just plot directly. So rest of the things I'll just plot directly and show you by my assumption. Next, we have object moving with increasing velocity. So this will be the third one. This is the second one. Object moving with increase in velocity. So increase in velocity means it is not uniformly increasing, it keeps on increasing. So then you have x in meters, t in seconds. So you have this kind of a graph, and next you have object moving in decreased velocity. So which means to say that x in meters, t time in seconds, and this is the decreasing path. So you can say that it is having a acceleration. Here you can say that it is having deceleration. This is how exactly you plot the graph when the object is at rest, when the object is with the uniform velocity, with increased velocity, with decrease in velocity. So when we just go on to it, the note is nothing but the slope of position time graph at any instant of time gives the velocity of the body, because remember, velocity means displacement by time taken. So their position is also there with respect to time. Position time graph is nothing but it gives the velocity of the body. The curve under the slope xt graph gives the velocity of the body at that instant of time is the note which you will have to remember, because it might be asked for 1 mark. Next we have velocity time graph. Till now we plotted about the position time graph. Now our duty is to plot regarding the velocity time graph. So this is your velocity and this is your time. Okay, same way everywhere you will have velocity time graph. Here also it is velocity time graph, and here also you have velocity time graph. So first of all, you just check. First one will be object moving with uniform velocity. Object moving with uniform velocity means to say that always its velocity is the same. So this will be the object moving with uniform velocity. And next, the second one, we just go to object moving with uniform acceleration. Remember, this is not uniform velocity, uniform acceleration, but starts from rest. When it starts from rest, it starts from the origin point from here. And uniform acceleration means each time there is equal increase in velocity, which means to say that this undergoes uniform acceleration. Next, we are getting on to object which starts from initial velocity. This is the third one. Object which starts from initial velocity and has uniform acceleration. So initial means not from the rest, it starts from some point and it starts having a uniform acceleration, which means to say that there is uniform change in velocity. Okay, so next we are getting on to the fourth one. So here the object is said to have uniform decreased acceleration. If it is decreased acceleration, the velocity, it starts from somewhere in the midpoint and it starts to decrease. Okay, so uniform decrease in acceleration means in a uniform way the velocity is getting decreased. That means to say that there is decrease in acceleration. Increase in acceleration will be shown by the graph in this manner, decrease will be this. Okay, such kind of graph you will have to plot by looking at the concept which is given below. If suppose you're not able to plot without any numbers here, you can just put the number and check how exactly the things goes on. That is all about this velocity time graph. So you have to note one thing, that is velocity time graph. The area under that curve, area under the curve of velocity and displacement is nothing but acceleration. Displacement of the body, it gives the displacement of the body, which means to say that it gives acceleration because displacement divided by time taken, that is change in velocity with respect to time, gives you the acceleration is the concept what we study. So that is all about your velocity time graph, and in today's class we have studied about the motion in a straight line, kinematics, what is meant by kinematics and kinetics, and we are studying about kinematics and about the velocity, what is meant by movement, what is speed, acceleration, instantaneous speed, instantaneous velocity, instantaneous acceleration and velocity time graph, and types of position time graphs. These are the things what we have studied in today's class. Let us all meet in the upcoming sessions of the same chapter and much more about the same chapter. Until then, have a good day. Thank you.